Okay, I'm going to try to do a real quick run through on how to convert to different numbering systems here and codes. So BCD and binary, this is binary, convert to octal and hexadecimal. So we'll go start with BCD being the probably the easiest. All it is you have to convert each decimal digit is represented by 4 binary digits. So this one, it's assumed to have a 0 here. So you have here, this is 9, and this is 5. So BCD, and you have to forgive my writing here on this pad thing I've got. It's kind of messy. So BCD, these digit in binary, this is worth 1, 2, 4, 8, and continuing in binary, this would be 16, 32, and 64. Doubles each time, as you can see. 2 to the power of 0, which is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4, etc., all the way through. So for BCD, each one, like I say, is 4 digits, and anything above 9 is not valid for BCD. So that we said the first one is 9, and the next is 5. So 59 is the BCD value. Convert, if we're going to convert directly to decimal is kind of the hardest one. It's sort of brute force. And the way to do it is you add up wherever there is 1. So 64 plus 16, that's 80, 88, none of these, 89. So in decimal, that number is 89. And like I say, all you do is you add up 64 plus 30, oops, no 32. So 64 plus 16, which is 80, plus 8 is 88. None of these, plus 1 is 89. So decimal 89. The hex and octal are the easiest ones. So we'll say hex first. Now, with hex, each 4 digits is 1 hex digit. So here we have 9 and 5. So if this was a BCD number, it's 59 in decimal. If it's a binary number, it's 59 in hex. If this is BCD, it doesn't translate to hex. It's only a code. Hex, or binary coded decimal, BCD, is a code, not a number system. And then octal, again, they're the easy ones to convert binary. So if this was binary, now octal, each 3 digits is 1 octal digit. So here, 1. Next 3 is 011, which is 3. And this one is a 1. So octal is 131. So just really quickly to go the opposite way, hex 59 we can easily convert back, so each 4. So again, it's obviously that. So we could make a different number. So we'll say hex, well, let's say A2 in hex and convert that. And as you know, 0 to 15 decimal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F is 0 to 15. So 2, 4 digits, you go 0, 0, 1, 0 is 2. And then A is 0 to 9, and then A is 10 decimal. So 10 in in binary is 1, 0, 1, 0. So this is the binary representation of A2. And if you went back the other way, this is 128, then 32, and 2, and you'd have to add it up to see what the decimal equivalent is. To go straight to decimal from here, it may be easier to convert this to decimal, but to go straight to decimal from hexadecimal, it's the same kind of a brute force method. So to decimal, you have to go, so this column, it's like with decimal, this is the tens column and the ones column. Same idea here, but this is the 16s column and this is the ones column. So we have 10 16s, which is 160 plus 2. So decimal is 162. And again, if you add this up, that's 128 plus 32 is 162. So it comes out right. Octal, we could do the 131. Let's just do, who knows, 41. 41, we could go to decimal. So decimal is same brute force method. This is now the ones column again. This is the eights column though. So 4 times 8 is 32 plus 1 is 33. In decimal, to go to binary is much easier. Again, 3 digits, 0, 0, 1, 3 digits, 1, 0, 0. So that's the binary representation. And again, you could go here. That's 1, 2, 4, 8, 16, 32 plus 1, 33. And it adds up, comes out. So that's it for the conversions. It's really, it's pretty easy. The going to decimal back and forth to decimal is kind of brute force method, and you just have to sort of do it.